Fantastic. I'm calling in currently from Rotterdam. Maybe that's our first question. You're calling it from Boston, I assume, or?
Yes, correct.
How's currently the situation in Boston? I mean, is it after work parties or no parties?
Definitely no parties. But definitely better than in other cities in the States.
Yep.
I just read that the United States is at 10% fully vaccinated. 20% at least have gotten the first jab. So slowly but surely we'll return to normalcy, but staying tight for the time being.
Fantastic. I think also most of the participants are calling in from Rotterdam. Some are still overseas. So all the four associations which have made this event, organized this event, are in Rotterdam and close by. So I also would say we kind of kick off now. So I hope everyone can hear me. That being said, I would say good evening, everyone. Welcome and thank you for all of you joining tonight's virtual event, Next Step in AI, which is all about human-computer symbiosis. In fact, it's well, good afternoon for Adam, who's calling in from the US. So also good afternoon, Adam. Shortly to myself, my name is Artis, and I'm a third-year business student at the Rotterdam School of Management, and will be facilitating and moderating tonight's event. The event concludes an exciting collaboration between the HonEURs Association, Erasmus Tech Community, RSM Club, and TU Delft Honors Community, who strongly believe that the discussion and implications of brain-computer interfaces is really relevant to all of us. Just before we get into the discussions per se, I would like to kind of brief out the agenda to make the next hour as smooth as possible. So the event will be divided into two 30-minute blocks approximately. First, I will introduce our speaker, Adam Molnar, and ask him questions which we hopefully lay the foundation for the second part of the event, which is a 30-minute open Q&A period, during which all of you are encouraged to post remarks or things that would you like to learn more about. In fact, we highly encourage all participants to join the discussions by using the raise hand functions in the participant section of Zoom, or by typing in your question in the chat. If you only want to type your questions, that's totally fine. You can just type it in the chat and then I will monitor and ask the question on your behalf. Also, you can ask the question by yourself by raising your hand, and then I will give the floor over to you. And please note that raising hands take precedence over questions in the chat. Lastly, in order to maximize the interaction, but I'm also very happy already now, we would like to encourage everyone to turn on the video, especially when asking a question, but only, of course, if you feel comfortable doing so. And also, the event will be recorded, so please let us know now if you have any issues with that. With that being said, I believe it is time to dive into the first part of our event, so learning more about Adam and Neurable's mission in the BCI industry. So first and foremost, I would like to welcome Adam Molnar and give you a short introduction about him. Adam studied environmental studies, specialized in behavior and entrepreneurship at the University of Michigan. While at university, Adam founded Bartex, a startup using machine learning to align transactions for cashless material and service transactions. And notably, Bartex was accepted to Michigan's tech incubator, of which Adam is actually now also a manager. In 2016, Adam co-founded Neurable along current CEO Ramses Al-Kaidi in Boston. And focused upon behavior and decision-making, Adam works directly with Neurable's partners to valuably apply objective neural insights for B2B applications. Moreover, Neurable develops BCIs, incorporating a headset with VR goggles and sensors that can read your brainwaves. And also, Neurable unveiled the world's first mind-controlled VR game at a conference in 2017. Possibly some of you have already read about it. In 2019, Neurable raised $6 million in their Series A funding to move beyond VR applications and develop an everyday brain-computer interface. And last, since 2019, Adam also holds a position as manager at Neurotex, which is one of the world's largest international neurotech community, uniting experts to drive innovations. And finally, and this is with great excitement to say, Adam joined Boston's Forbes 30 under 30 board in 2021. So yeah, very welcome, Adam, from my side. So a lot has been said. I would like to give the floor over to you, Adam, maybe to also introduce yourself if I've missed anything, and tell us a bit more about your career and current work at Neurable.
Yeah, no, thank you so much for that, Artis. It was nice to hear. I think you covered most things, but basically I had a little bit of an atypical path to where I am right now. I currently am co-founder and head of partnerships at Neurable. So my work is largely connected with working with other organizations to fill in the gaps of my company. So some of our partners include people like Red Bull's High Performance Lab, or the US Air Force's research team, among others, that we're moving a bit away from virtual reality, as you were mentioning, with that everyday BCI concept and targeting consumer end users. And we can get into more of that later, but just a helpful preface.
Fantastic. I mean, as you said, I think we should dive into that. Definitely what actually everyday BCI mean. I think that's probably also still some new word for someone. And in fact, I think that's also one of the first questions some would have anticipated. If you could just briefly explain what actually a brain-computer interface is. I mean, there's different approaches to it, but maybe from a Neurable perspective to someone who's, well, new to the industry, such as I think most of the audience.
Yeah, I'll share two perspectives. One is like just a technical explanation of what is a brain-computer interface, or BCI. So basically, your brain produces data in the form of electrical activity, or actually also in the form of oxygen level changes. And those can be picked up from invasive or non-invasive systems. So an invasive system would be you have to open the head to actually through the skull to place sensors in the brain or on top of the brain. Non-invasive systems include things like EEG, functional near infrared, and a handful of others. And what those are doing are looking at how the brain works and trying to make sense of it. I'm sure some of you have heard of an EEG before, or an electroencephalography. That is the technology that Neurable works with primarily. And what we do is we work with a dry EEG system. So long as the sensor is touching the scalp, it can produce when one cell communicates with another, produces an electrical signal. When big events are happening in your brain, that produces waves and patterns of these signals that go through your brain into your skull and then just barely into your scalp and into our sensor. And then what we do is we use algorithms to help make sense of that, because the signal is very faint and it's very hard to make sense of it, but there is a lot of valuable data there. So that's like the high level explanation of a BCI. But I think another concept to help keep in mind what helped start Neurable was this idea that every major computing platform has a companion interaction modality that brings it all together. What does that mean? It's like before the personal computer, we had computers that were the size of warehouses that you had to feed with a punch card in order to tell it what to do. So unless you were like a very specialized engineer or a scientist, you were likely not working with it. And it wasn't until the personal computer came out with the keyboard and mouse with a graphical user interface that we know as like a visual interface, that it became more accessible to lay individuals. And we see something similar with that when it comes to smartphone technology, that before Apple made the capacitive touchscreen the standard for smartphone devices, we had smartphone technology about a decade before. But it wasn't until there was this intuitive interface that we could fully take advantage of the medium and the potential of the system. And what we see with that is with every generation of computing going from normal computers to smartphone technology to now we see immersive technology, we see the gap between human and machine diminishing at every stage to a degree where we literally talk and touch our devices, whereas that would have been a crazy concept only 15, 20 years ago.
It's fantastic that you're saying that, because in fact, that diminishing space was, I think that there was a quote by Elon Musk, I mean, to the others, who also runs Neuralink, who has said, I think, in fact, we're already in a symbiosis with our phones, just most people don't realize it because it's outside. Maybe touching upon that, what you also said in terms of invasive and non-invasive BCIs, what is the current state of the industry? So I think we see a lot of startups being in their Series A, Series B funding. There's nothing yet finally on the market, as far as I know. Yeah, how would you describe the current industry stage? What is happening there?
Yeah, it's a great question. There definitely are products on the market, but there's a reason why we don't have them yet, and that's because there are so many limitations when it comes to consumer brain-computer interfaces. Mm-hmm. And I can break down those gaps in a moment. So there is this consumer BCI area of products, which is largely in the meditation / wellness space, mm-hmm. or for the very niche hacker programmer that like just want to experiment and rapidly prototype. The key difference is that the systems that hackers or like tinkerers use for prototyping are probably like an order of magnitude or 2 order of magnitudes less reliable and also cheaper than what is research grade. Mm-hmm. So Neurable, when we first launched and had that virtual reality product, we combined research grade material with a consumer and customer, which allowed us to do really good things, but ultimately we didn't make a very good product. Yeah. I'm happy to get into that later, but there are a couple key areas of where consumer BCI is currently lacking. One is in the form factor, that you can't have a product that looks like a piece of neurotechnology if you expect it to catch on with millions of people. Yeah. The approach, and now we're hinting towards what is the everyday BCI, is we follow the Fitbit Apple Watch model, where what they did was they just created a watch, and it was a great watch, and it just happened to also have biometric tracking. Yeah. So we take a similar approach, and I can't fully say what we're working on. Basically, I can say that we're working on a pair of headphones that we're going to announce very, very soon, so stay tuned for that. Mm-hmm. But yeah, so form factor is definitely a big one. There is the value of the algorithm, that like a lot of the software that exists in the field currently, honestly, it's hard to tell if it even works or not. Mm-hmm. And that's by no sacrifice of other BCI companies in the field. It's just a very hard technology. But when you have so many things working against you and trying to make BCI happen, you likely have to make concessions in terms of what you can do. So it's like, maybe you're going to use cheaper sensors, which leads to not as good performance. Mm-hmm. Or you're going to use really expensive sensors and have great performance, but then the price point might not be at the consumer level. Yeah. I'll pause there for a moment because there are a couple other gaps, but does that make sense so far?
Fantastic. I mean, when you said headphones, I presume the sensors are in this upper layer here, but that would be a assumption. Maybe if we're already on that, what the challenges are. So essentially, you would say that the biggest hurdles currently to really commercializing it and making it well, probably not tomorrow, the mass market product, but in the years to come, is kind of adapting it and seeing where it is applicable, because that is also one of my questions. And I think probably for most of us, where do you see the biggest, possibilities in terms of implementation? I mean, is it going to be in medical, in the medical industry for people who are paralyzed, as we've already seen that kind of come up? Where do you see the first big opportunities to open for BCIs?
So what you mentioned is like you're talking about where the opportunities for BCI are currently, which makes sense. Like the reason why people with severe disabilities use it is because they have no other options, because BCI is historically such a hard technology to work with. Mm-hmm. And I think it also warrants a distinction here between invasive versus non-invasive, because invasive is always going to be more effective than non-invasive, but then you also have the challenge of scale and allowing people like you and me to go to the store and buy one. Yeah. So if your question is where do I think consumer BCI will find its foothold, I would say it is very similar to the wearable space, where we have these products that give us basic data with actionable insights about our fitness level. And what we're working on in Neurable is a wearable, a cognitive wearable that gives you basic data with actionable insights, but instead of about your fitness, it's more about your cognitive well-being. Mm-hmm.
It's quite interesting because, in fact, I was also wondering, in the sense, of course, of Neurable's industry positioning. Then, if you say that invasive ones, like as I would suppose, Neuralink, are more effective, is Neurable's maybe strategic positioning towards more capturing more the commercial market, or how would you say? Are you also differentiating between competitors? So, what essentially would you say makes Neurable?
Yeah. So actually, I think effective is the wrong word, because effective should pertain to what is the use case. So invasive sensors will always have higher quality data, which will allow you to do more, but they might not necessarily be effective at a consumer use case.
Yep.
So what makes Neurable different is we tackle a lot of the gaps that we found in the consumer BCI space, which include form factor, the value of the algorithm / the performance, the cost of the device. We're actively working on one of the social challenges, which is like people just don't know about brain-computer interfaces or BCIs yet. Yeah. So one of the big things that we're working on is an education effort. Actually, selfless plug, we lead a thought leadership series every month where it's completely open to whomever's interested. So if anyone's ever, I think our next one is Focus on Your Focus, speaking with experts in the field about what is focus and attention and how can we feel better about how we work.
Yeah.
And by working on all of those gaps at the same time without sacrificing one or the other, we think that we're making the best bet for what will be a consumer product. So it'll be priced competitively to another known technology or product that you wear.
Yeah.
It's going to be something that you would want to wear all the time, as opposed to just for a niche application. It's not going to cost you an arm and a leg to use it, and you're going to understand what's coming out of it.
It's fantastic that you're saying that, because I find it so interesting, because people, I think, decision-making barriers towards just having a watch on your hand which tracks your pulse, for instance, or how many steps you've taken, is different than having something connected to your brain. We perceive the brain as, something which is us. And I think that is also one of my last questions, in terms of like, where do you see the evolution of mankind, popping up a big topic here, going? Where do you see this going, that that we say which part of us will possibly be actually the BCI, maybe assisting our decision making, assisting our everyday lives, and where will we be? So is a cyborg the new human sapiens, or maybe a little bit of future thoughts?
Yeah, so I have a fun answer and like a practical answer. The fun answer is like, at some point in time, when we're able to understand brain activity, we could have all sorts of applications to a degree where we're able to communicate without having to speak, or we can imagine words, or have that level of semantic capability, or what we call effective computing, where it's like, imagine an experience where you're watching a movie, but the movie understands the emotional state you're in and can change with that in mind. So that's the fun answer. The real answer is that's quite a ways away. And
we just have the panel discussion without speaking. I'm just looking at you, and we exchange our thoughts.
Oh, so that's what you have for lunch today? Okay. No. In all seriousness, like I do think, and it's to no fault of anyone, that when people hear neurotechnology, their minds first go to magical powers, or like the force, when in reality it's going to not be that sexy. It's going to be much more practical. That like, and I think it was interesting because you're pointing out about fitness and like and wearables, that those data points have feedback associated with it. What that means is like, when you take a step, or you can more or less understand when your heart rate is elevated. What we don't have is a feedback system for how our brain is working. And that is one of the really interesting things that I can't wait for this to be out and see how it affects us, because it essentially gives us a new way of listening to ourselves in a way that we haven't really had before.
Interesting, yeah. In fact, you're just raising a new point that I have never thought about either, that we become reflective of ourselves instead of always questioning the who am I. Now of course I still have to there's of course that big question in the room. I talked to some participants before, these ethical concerns pertaining to BCIs in particular, coming back to what you just said. People always think in terms of neurotechnology, in terms of superpowers, and the rich can afford them, and that they become quantum computers just by a chip in their brain. The wealth gap is increasing. Now, of course, might still be some big words out there, but there possibly is also some truth to that. So, how do you see maybe still future societies evolving once BCIs become more commercialized?
So there's the near-term answer, and then there's the long-term answer. And I think before that, I should say, can you hear me? I think you froze.
Yep.
Okay, cool.
My apologies.
No, you're good. Neuroethics is an extremely important topic. It's one that Neurable talks about quite frequently. One of our engineers and myself, we published a blog post several months ago about the subject. Actually, our head of marketing just published another post about it with Neurotech X, the organization. So it's a conversation that we're having quite frequently. There's a really awesome, I won't dare pronounce it, especially with all of you on the call, but there's an awesome German think tank, and we've been speaking with their project lead for ethical use of data, in addition to a bunch of others who are blazing the trail for ethical uses of AI, data, algorithms, etc. The conversation does change a little bit when we start to talk about biological data, especially neurological data. But the long story short is it's important, and I think it's up to the companies who are paving the path to set the tone so that other companies can follow suit. Like at Neurable, we were transitioning from virtual reality applications to our next industry with our next product. And we had to ask ourselves, do we want to, what do we want to do with this technology? And we were offered a good amount of money from companies to do what's called consumer research testing, and basically how can we use this data to help engineer ads or products better. And ultimately we decided that that's not where the heart and soul of the company is. So we take a very Apple approach where and these are some of the basic tenets of good data policy, that good data policies are when data is being used to directly impact the person from whom the data comes. So if they own it and they have it and they have conscious say about how it's allocated, that is quote unquote good applications of data. And those are the policies that drive everything that we choose to do at Neurable.
Yeah. I mean, I think it's also quite, of course, in terms of law perspective, interesting, because the entire policy making is new. I mean, the question is always, does technology precede and policy follow, or does policy maybe precede and technology follow? Still, one of the questions I have, and I think that will be the last one. I already saw the first question from the audience coming in, is in light that I have an exam tomorrow. I mean, when do you think will the moment come when I have a chip in my brain and I upload my summaries instead of just reading them? So the switch from a reflective measuring of a BCI towards a maybe actually brain enhancing capability. Yeah.
I am not the authority to weigh in on that. Unfortunately, I think that's quite a ways away.
Yeah. Unfortunately,
my specialty is in the non-invasive domain, so we don't try to change the brain. We merely try to understand the brain.
Okay.
And I think that's a very different type of technology that you're talking about, and one that we should talk about now so that we can prepare for it when it comes in decades, probably. But I'm sorry, you will have to just study for your exam tomorrow.
Okay. I mean, fantastic insights, I think, so far. I have from my side also still a lot of questions. But considering that, I guess there's a lot of questions from the audience as well. As long as there's nothing still you want to share before we dive into the Q&A, I would say we open the floor to all participants. So you can raise your hand if you want to speak up, or just type it in the chat. I see the See no hands raised for now. I have a question actually from Sheila coming in, which also taps into another question from another participant, which is, can you elaborate on your mind-controlled VR game? So I think that was for all of us, great to see how to play escape room with the VR camera, Google on. Yeah, if you could a bit elaborate on what the testing was behind it, or yeah.
Yeah, so that's the technology that put Neurable on the map. So in 2016, we spun out a technology through the University of Michigan's Direct-to-Brain Interface Lab. My co-founder and the CEO of Neurable was the inventor. There's a neural response called a P300, which is an event-related potential. And basically what it is, it's a subconscious response to a stimulus in your environment that you care about. I'll give you an example because it's a tricky concept. Yeah. How it's used historically is with people who are considered locked in, who have no other means of communication. So they're shown a keyboard, a digital keyboard, and they flash every letter in a sequence. Mm-hmm. And the person, because they want to type something, one letter becomes more meaningful than all of the others. So when that letter gets flashed or stimulated, they have a specific neural response that can be captured. Mm-hmm. That's the P300. And historically, it's taken anywhere from 10 to 20 minutes to, 10 to 20 seconds to identify that neural response. Our innovation was to be able to use that and reduce it to about 1 second. With a much less cumbersome hardware, mm-hmm. and with a much shorter calibration period. Mm-hmm. So we took that technology with the idea that, and also in 2016, virtual reality was at the peak of its hype bubble. So we built this retrofit that you could wear with the HTC Vive so that you could use the P300 as a control modality. You could basically like mentally want to pick things, because when it mattered to you, the computer would essentially guess that it mattered to you and use that for control. Yeah. So we then in 2017 showcased the demo at a conference called SIGGRAPH, and that was very fun, but it's gonna sound like I'm bragging, but I swear I'm not, because I'll knock myself down right after. But the demo was awesome, and it got us the attention of everyone. It got us the cover of the New York Times. But the technology, like, it unlocked every door with anyone we could ever speak to. But time and again, when we spoke with them and figured out how we would roll it out, they're like, so what? It's a really cool demo, but not a super practical technology, at least right now. Like, we could see where it will be in maybe 10 years, but how can we work with it now? So that led to a series of changes and iterations to a point where we started to work with virtual reality training. Mm-hmm. So we had this because in virtual reality training is where VR found its foothold commercially. And this are the series of steps that led us to the everyday BCI, that we realized that for us to really have this impact that we'd like, for us to be able to make neurotechnology ubiquitous capability, we would need to make it in a way that people would want and would normally wear it casually. And so that's a long story short of how we went about the awakening. I could talk about that for like, I don't know, hours, but.
Fantastic. I hope, Sheila, that answered your question. The next question I see coming in is from Marin. Marin, I would give you shortly the spotlight, and then you can ask your question by yourself.
Thank you very much, Artis, and also Adam. So I was wondering how BCIs, in your opinion, could feed into anti-democratic surveillance, or also the power that multinational companies already have over us, and how that could develop in that sense.
It's a good question, and it's a tricky one, because it's not so. When I think about it, I don't think about it necessarily as BCI. I think about it as technology in general, that your smartphone produces much more identifiable information about you and telling than a current BCI would. But that doesn't necessarily matter. The fact that people care about their brain data is enough that it's important to us and to our end users. So our stance is transparency. We tell you what we're collecting, why we're collecting, and where it's going. In terms of like anti-democratic applications, I think that will come down, unfortunately, to like policy and people demanding that this is how technology is used. I think that the builders of the technology surely have a role, because ultimately it's their company culture that will dictate the paths that they take. Like how I mentioned, we were offered a ton of money to help people make better ads, but we're like, we would rather people feel better about how they're working. But so that's on the builder side. On the other side, I think it also really comes down to customer. And it's tricky because like you need the customer to be informed, because there's so many people who sign away their data because they don't really understand what it's being used for or what the implications are. But if we ignore that very tricky subject for a moment, the end consumer, the customer, decides what product is going to work and what product's not going to work. If there's a big brother company that has a product, and then there is, I don't want to say Neurable, but let's say there's Neurable, the kid guys, it will be to the end customer to decide who they give their currency to, because ultimately by doing so, they're fueling the progression of one person, one team versus the other.
I think Martin's question, your question is again also linking to what we talked previously. That we say we underestimate, maybe even at times, how invasive actually our phones are. Not only in our everyday time that we spend, but also in our decision making actually, and the subconscious the steps we take. And it comes back, I think, again, that we say we have something in our hand or in our hand which we can kind of throw away like a phone, but something which is attached to our brains seems so close. Martin, I hope that answered your question. Do you want to maybe follow up on that, or is that clear to you?
Yeah, maybe in like which direction policymakers could then like restrict that problem in some sense. So should they only make it possible for some companies to work on BCIs, or only in some particular areas such as medicine?
I don't think you'd want to restrict who could work on it, because then you're restricting the amount of progression you can have. I think, and granted, I'm not a policy expert, so I know where my areas of weakness are. But regardless, I think this is a really good question to ask, and it's people like you that will help people talk about it more and more. I think it will come down to not necessarily preventing, but trying to block the malicious areas. And it's a very different approach to allow innovation to happen versus to, and it's like a nuanced difference, to allow things to grow and being able to say, no, this is where we draw the line, versus to draw all the lines and say, only build in this direction. Because I think if you were to restrict it to medical applications only, will stifle innovation and will make it very slow, because the medical industry operates so much more slowly than any of the other ones. Like there's a reason why our first demo was an escape the room virtual reality game and not a keyboard speller for someone with severe disabilities. One of my favorite case studies of all time is the Apple iPad. I don't know if you know this, but so in the field of AAC, which is assistive augmentative communication, so it's for people with very severe disabilities, the iPad is the most commonly used communications device. And they were able to be that because they were able to leapfrog so many challenges of red tape and policy, that they could bring value to the end user faster than if they were to have gone through clinical trials and then FDA approval, and then slowly roll it out. I hope I answered your question.
Yes, thank you very much.
Thank you so much, Maren. I would then give over the question to Myrte. I see you were raising your hand, and then I would give it over to Eva afterwards. So let me just give you the spotlight. Here we go.
Hello, yes, thank you. I hope you can hear me.
Fantastic.
Correct? Okay, yeah. So this is very new to me and also very exciting. So I was wondering, Adam, if you test the products yourself, and if so, do you have any takeaways? Could you see it when could you see it being in your daily life?
This is a hard question because we haven't fully announced our next product yet, but very soon.
Yes. Okay.
I know it's an annoying question. I can't wait to answer it normally. Sorry, it's an annoying answer to a good question. And I can't wait for you to experience it yourself.
Maybe for us merchant in that sense, I mean, when do you think we'll even be in Europe be able to test the products? I mean, is that something you can say
is a bit like outside of the US is a bit more challenging because you need to go through a certification process that adds 6 to 8 months longer than it would be for the internal launch. So when I say internal, I mean for the US.
Yeah.
So it will be about like 6 to 8 months after we launch it in the US. So like we're announcing the product soon. The product will come a bit later. But like I'm currently working with the functional prototypes and beta units of our product right now.
Fantastic. Yeah. Mert, I hope, I mean, that was half a question answer. If you have a follow-up, feel free. Yep.
No, I think I'm good for now. It's
fantastic.
Can't wait.
Okay. Yeah. I'm just gonna remove your spotlight. Next question goes to Eva. Gonna give you the spotlight. Here we go.
Yeah, it's great to see you here tonight, Adam. Thank you for joining. My question is, what does a typical Neurable customer look like?
That's a great question. So for me right now, on the partnership side, I'm working with organizations that are focusing on human performance. So the people who are looking at technology to see how we can boost what we know of as performance, like how can we learn better, how can we feel better about how we work. But that's on the more B2B side. Our target customer for the consumer product are people who are working at a desk specifically, and we're about to give a couple big presentations in March about this. My co-founder speaking at South by Southwest, talking about neurotechnology and the future of work. Future of work is a really key concept because it's looking at what technology has done to how we understand work and how we then ebb and flow with those relevant shifts. So if you are a person that's working at a computer, you are likely a potential customer for Neurable. We're trying to go broad and be extremely inclusive. We have a tagline at our company that I really like, and it's from my co-founder Ramses, that we're trying to build as a world without limitations. That the products that we build, we try to make it as democratic as possible, so it's giving the same kind of benefit to you or me or whomever, if they're differently able or not. In addition, someone asked previously, I think it was Marin, about the price point and it being prohibitively expensive. It will not be this product. I can't say the same for invasive systems, which we don't work on, just to be clear. That's a hurdle in and of itself that I'm very curious to see how it plays out. But fortunately, I think we have a good amount of time to figure that out as well.
Cool. Eva, is that answering your question, or do you also want to have a follow-up?
Yeah, it does. I'm wondering if you're saying like a person that just works at a desk, do you think like the whole topic of brain optimization is becoming like a trend in the future, just the same as like the Fitbit that everybody wants to hop on?
It's an excellent, yeah. It's actually an excellent question. I just wanted to also touch upon that because I'm, for instance, using my heart rate sensors to for interval sprints. Question is, why not use a brainwave sensor to measure when I should start and stop studying? But so yeah, just want to say it's an excellent question. Yeah.
Well, we may or may not be working on that. So.
Well, I mean, let's hope it becomes a trend then.
Right. So I don't want to say trend because that feels like something that comes and goes. I don't want it to be a fad. What I do think is very important to point out is that today it is more important than ever to understand the impact of mental health and mental well-being. And that is the underlying principle that's guiding this current product. There are elements of hands-free control to it, but I'd say those are side benefits to what is the core value. So to answer your question, like it's got to be part of our conversation. This technology needs to happen. And I say that with a very strong asterisk because technology is not the problem to all of our problems. Sorry, it's not the answer to all of our problems. That it's very much a double-edged sword, that it needs to be done intentionally and also with an amount of awareness, because whenever you have something new, it's very likely that there are unknowns, and they're also very likely to have unknowns. So the things that you don't even know to anticipate. And that's where it gets really challenging, because a well-intended product, service, tool, et cetera, could be used very negatively if not monitored and kept in check. So good question.
Fantastic. Yep. Eva, all good?
Thank
Great.
you.
A question came in from Nasim. Quite an interesting question, I would say. He's asking, what is the main field you're focusing in except of signal processing in BCIs? What does this device look like that connects between the wired brain and the external devices? So I think he's focusing really on, the connection, probably also the interpretations of our brain waves. Nasim, please let me know if I understood that question correctly. Otherwise, I would give it over to Adam.
So I'll clarify two concepts because there are a lot of dense words that were just said. Signal processing is one of the areas that we specialize in. It's the idea of there is data available to us, but how do we make sure that we're getting, one, enough of it, two, a good enough quality of it, and three, in a way that it ultimately then makes sense to our algorithm so that we can interpret it in a relevant sense. I think it's like helpful to think about a pyramid, right? Where electrical activity in the brain, which is cellular communication, is EEG, electroencephalography. A layer on top of that is how do we understand EEG activity and the level of like, what are the relevant heart rate zones are called frequency bands, where there's alpha, beta, gamma, theta. A layer on top of that we call correlates. So how do we look at patterns in changes of frequency bands to infer behavior? And on top of that is maybe something like an attention algorithm or a fatigue or arousal estimation. So I think it's helpful to think about it in terms of theirs. So that's what I wanted to square that way with signal processing. But then there was another component to talk about what is the actual hardware that allows for all of this to happen. So there's a conductive material that is on the skin that's capturing the fluctuations in this electrical activity.
Do I have to shave my head then for that to be on my skin or no?
No, you can see my co-founder Ramsey. He has this very long, flowing, beautiful hair.
Okay.
And those people are. So if it works on him, it works.
Fantastic.
But yeah, so there's a hardware layer that's collecting the electrical changes. Then there's usually an amplifier component that's taking this very faint signal that's coming through the skin and making it louder. Then that is sent to a computer. The computer then processes it, usually cleans it, because there are a lot of things that can mess with the signal. That clean data then goes through a classifier. That classifier is it's using whatever model or algorithm you have to output whatever you're looking for. So like, let's say you're looking for hunger. I'm not saying that you could. It would take in this data and the algorithm would crunch it, and then it would spit out, okay, we think it's either a hunger score of 0 to 100 or however you would visualize the data output. But you can have that connection through a wire or through Bluetooth. There are numerous ways to go about it, but basically the challenge is how do we get what's in here outside and understood?
Well, I have to say,
it's a very good answer. Thank you very much for the explanation. I wanted to understand a bit the design approach that you used. So if I can ask maybe another question that is a good follow-up on the actual one. Sure. It's in order to consider now you're working on an AI engine. In order to consider a product very effective, it depends on the number of logs that it's collecting, and usually it's for many years. If you just like compare like different like vendors, the results, they are not the same. For example, like Samsung and the Apple. So for example, in your case, the collection of data, you are doing it like for already how long?
For 5 years. So I think what you're asking is like, how do you build algorithms that require so much data from a system it's so hard to get data from? And that's one of the critical components of why BCIs are so limited, because like, who here is collecting their brain data on a semi-frequent basis? That it's not very many.
I'm doing it in my headphones, but.
And you're my competitor. I don't know what to tell you. No, but so we've been working on this for 5 years, and it's a very expensive and tough process to collect all of this data. But fortunately, we have investors who believe in what we're doing. So we've raised over $12 million so far to be able to do what we're doing. And I think it's brought us just to the level where we're performant enough that people will now want to use it on a consistent basis.
Okay, cool. Thank you very much for the answer.
I have to say, as a business student, there were a lot of terms which I have to check up upon. But it's great that we have a lot of people from the technical university in Delft. That I would also give the floor over now to Juan for his question. I will just give you the spotlight, and you can ask your question.
Thank you. My question is, how much information can you actually extract from the electrical signals that you obtain with these non-invasive devices? Because, for example, you can have a thought like, I'm hungry or I'm relaxed, which should give a kind of output, but there should be like more complex thoughts, like a political opinion, for example, which maybe you cannot extract a priori the information with this. What are the limitations in these kind of things? That what can you know and what you cannot?
This is an easy question to answer because it is much more limited than you think. Like, we could not know if you're hungry or saying specific words. Like, that is not the level of data, the granularity of the data that you can get yet. Right now, what you can do is you can look for large macro level changes. So like bigger shifts in mental states, or if you train an algorithm for a very long time and you have all the hardware and all of the signal processing and machine learning techniques, you might be able to do things that are a bit more elegant than that, which we may or may not be doing. But I think some of what I can tell you is what are some known neural responses that are really exciting that aren't necessarily available to consumer form factors, but like definitely something that at least at Neurable we have in mind. One of my favorites is this idea. It's a class of event-related potentials. It's called error-related negativity. So it's when you notice that you've made a mistake, you actually have a very particular neural response. There's another class of brain activity called motor imagery. That's when you imagine a movement. So like people use this in laboratory environments where they have an individual practice like going like this, but then and not actually physically making the motion, but imagining the motion. And over time, with a lot of learning, you can actually train an algorithm to see that brain activity so that you could do that yourself. And I think that's probably like the closest that we'll come to like feeling the force, at least in like the next 5 to 10 years, maybe longer. But yeah, sorry if that popped your bubble.
No, that answers it. Thank you. Thank you very much.
Fantastic. Well, it was a great question, I have to say. The next question is from Roy, who texted, what is the typical order of magnitude of electrical brain activity that a BCI is able to sense? I expect Roy to study also something related to the field, but yeah, Adam, if you could answer that.
Roy might know better than I do. As you mentioned in my introduction, I had a very atypical path to Neurable. That my background was in sustainability and consulting before I fell into a neurotechnology company. And I largely am on the business side. So Artis, you and I, we could probably talk for a little bit longer.
Yeah.
I would defer to one of my staff scientists for that question.
Because Adam, that was actually also one of my final questions that I would wanted to raise before we conclude the event is, considering now that, you know, I heard a lot of, you know, a lot about algorithms, a lot about, you know, neuroscience, of course, also you as a business person, how is actually Neurable's team made up? And how, in fact, maybe does communication work? Who comes from which fields? How do you build that up? It's quite fascinating to me.
Yeah, that's a great question. There are about 17 of us right now, primarily in Boston, but somewhat distributed. So we are definitely more technical than we are business or marketing. Sorry, marketing is business, but anyways, the format of the team is largely doctoral PhDs in what are the disciplines? Electrical engineering, comp sci, biomedical engineering, computational neuroscience. We generally recommend, at least from a technical field, to have more of a computational background with a specialization in biological data, as opposed to the opposite, where we wouldn't necessarily like go for a neuroscientist who has like done a little bit of computer science. We usually go for a computer scientist who've done a little bit of neuroscience and then turn them into neuroscientists.
Yeah.
So that's at least our technical makeup. And then we have a VP of product who's a former Bose product executive. Makes sense for our next product.
Yeah.
We have a VP of engineering, and then it's myself that is the head of like business development. And we have a small marketing team. Yeah.
Okay. I mean, yep, please.
For those who are more interested technically, we have a blog post on our website of recommendations of how to break into the BCI industry. And we also, and this is for anyone, we have a Discord running for anyone who's really interested in the space. We have our scientists in that chat all the time answering questions. I'm in there. I should be in there more often, but I'm quite busy.
Yeah.
It is a really good resource for anyone that's interested. And I also really recommend looking at Neurotech X, because that is like a shit ton of resources and other really interested people who are in the space.
Fantastic. I think it's always fascinating because also we see it now. We have so many business students here, but also tech students. And I think bridging, you know, our way we communicate is quite fascinating. I see Lucas has a question. I forgot actually to say I would love to have the participants short introduce themselves when you ask a question. So Lucas, if you could just maybe say what you're studying. Then...
Yeah, I'm studying in Delft at I'm studying applied earth sciences. It's not really my field, but I'm very interested in it. And I was wondering, because you said that you were focused on delivering this to people working in offices and stuff, but obviously there's also huge application for people that have lost limbs maybe, or that have some mental state that they're paralyzed. I was wondering, what's your vision? What's driving you? What's your vision for the future of this technology?
So the first part of your question was, why aren't we working with paraplegics or people who are differently able, to give them that sense of control? Our stance is that we need to make something that's really successful so that we can rush it out. Sorry, we can spread it out, make it ubiquitous. There are many other companies that are working on prosthetics, but I think it's also a helpful segue into what is the actual inspiration of Neurable, and why do we say a world without limitations? So my co-founder, Dr. Ramses Alcade, he's an immigrant to the United States. He grew up he was born in Mexico, but was raised on the West Coast of the US. When he was really young, his closest uncle got into a trucking accident and lost both of his legs. So it's been his life mission to build this kind of technology. So we've been working on it. And he initially started out with prosthetics, but in his undergrad, he was an electrical engineering student. But he realized that if he was really going to affect change, he had to target the brain. So that's how we got into brain-computer interfaces and are building these capabilities out. So our approach is like, how can we get something out to a lot of people? And when we do that, we then have the power and influence to build these more specific applications to help more people. But the product that we do put out is not limited to just you or me at a desk. Anyone can use it. It's just what is our like market rollout strategy? Because at the end of the day, we are still a business and we do have to show growth and value over time. So it's a tricky line to walk, but I think ultimately a fun and fulfilling one.
Fantastic. Lucas, I hope that answered your question.
Yeah, so your goal is really to bring it out to the masses, and by doing that, being able to help everyone basically with
yeah, this, I don't want to call it cheesy, but I feel like I see it very often in like a lot of HR companies. It is the picture of the three individuals watching a baseball, or like it's a sports game, and there's the individual who is watching who is like, it's a fence that covers the game, right? So there's one person who is stepping on a box to watch the game. There's another person that's lifting a person up to watch the game. And then there's another person who is off to the side and he's watching the game through a fence. So what that's trying to tell is you can have artificial resources that allow someone to have a leg up, like have it coming from like a wealthy family or being normally able. You can have someone help another person, which is like putting someone on your shoulders so that they can see, but you're ultimately burdened as well. Or you can delete the obstructive challenge so that it doesn't matter whether you're short or tall, you can still watch the game. And that's our approach to what we're doing.
Fantastic. Adam, I also, looking at the time, we have 3 minutes on the clock left. I received a very interesting question. Can you take one last question, or yeah?
Sure. And I do want to say like a couple of plugs, but go ahead.
Perfect. Jose Ignacio, he raised a quite interesting question. He said, given that different parts of the brain are used for different purposes, I assume it is very difficult to develop a wearable that can tap into all of the brain's regions. Do you think the future will consist of multiple wearables for different purposes, or a cap that can assess the complete brain? I can imagine that forcing the user to purchase multiple items for different purposes can be tiring expensive. Quite a practical question, but yeah.
Yeah, and I think one of the challenges is you have to think about the matrix of what will allow for a product to be successful. So granted that there are other dimensions that I haven't talked about, but if we're looking at cost, form factor, value, and social acceptability, it's very hard to hit all of those buckets to have a successful product. So like we are focusing on specific brain regions to do a specific type of application because that's what's available and we think that's what's going to work. If we wanted to do more comprehensive things, yeah, we would need more sensors in other locations. But I think that we need to first start the dialogue about what is neurotechnology, can I have it in my hands, and why I should not be afraid of the technology, instead embrace it. There's still a lot to learn before expanding it. So like if there's a challenge about buying multiple products, maybe I'm focusing on one problem at a time.
I think it's actually also fantastic. I think ending that you say, we have to take the fear away, and as every industry, it's going to go step by step. Yeah, I think I think this is the beginning probably of many more questions and discussions. Maren just texted me as well saying, can we possibly take a picture all together for everyone? So I would encourage everyone to turn their cameras on if possible. If not, then not. Let me give it 1 more minute if that works. So see some cameras being turned on. Fantastic. Thank you. Thank you. Thank you. By the way, also Eva and Sheila posted in articles and links that Adam was talking about. So if you want to tap into that topic even more, free feel to do so. Maren, I would give you the power to take a picture of everyone. I see we have too many for one screen, but I'm sure you'll manage.
Got a shot.
So. Thanks.
Fantastic. Okie dokie. Then I would say, with that being done, I would thank Adam so much for your time. We know you're very busy and probably, especially considering the new launch. So
yeah,
thank
before
you.
you go, do
Yep.
keep a lookout for the launch. It's coming very soon.
Yep.
We have a monthly thought leadership series that I'm happy to send your way.
Mm-hmm.
I wanted to mention that about 10 years ago, I was exactly where you guys were. I did a joint American Erasmus program in Barcelona. So I'm jealous of all of you and wish I could be in your shoes right now.
Yeah.
Join the Neurable Discord. It has a lot of gems. Specifically, I want to plug, especially given Women's Month, we have a Women in STEM channel that's specifically for those people. That's led by some of our neuroscientists, specifically Dr. Mavi Ruiz del Blossom. Ruiz, she's great, and we have a lot of really great resources in there. It's a lot. Follow us on social media. I'm active. Friend me on LinkedIn. Happy to continue the conversation going. If you ever find yourselves in Boston, holler.
That's just wanted to say, probably some of us will maybe do their masters, come over there, so we will let you know. I think I already saw some posts on LinkedIn, hashtagging Neurable. So yeah, thank you so much for the follow-ups. Thank you for all participants for coming. I hope to see you soon at our events. And Adam, again, thank you for your time. Talk to you soon. Adios. Ciao. Ciao.
Thank you.
Ciao, ciao.
Thank you.
Ciao.